All right. So for the null lab, one thing that I guess, we really want to point out is, right, like, let's do this one. Yeah. Okay, so this says, okay, select some of the rows. Find the number of rows where the home phone is null. So I'll just delete this. So we can do select count star where home from persons, I think, is the name of the table. And it's like where home phone. You can just put is null, and that should work out fine. And if you just do, select star, right, this gives you all the rows where home phone is null. But if I do count star, right, it just gives you a single row. It's really valuable just to keep track of the dimension when you are writing SQL, like what your query will do to the dimension of the data. By the dimension of the data, I mean the number of rows. Okay, so right, just like a simple where clause that gives us, I don't know how many rows. It looks like 224. And then if we do count star, it gives us one row, and it counts them up, right? And we can just do count star as missing home phone or home phone null, it looks like. Okay, so this is giving us that number of rows because this is all the cases where home phone is null, and we're counting the number of rows. That's what count star means, like count the entire row. If you just do count home phone, think about this. If we did count home phone from persons where home phone is null, like what will this return to us? So this returns 0, right? Does this make sense as to why? Because if you're counting just an individual column, right, what that means is count the present values, the non-null values of the column. But in this case, we're counting the non-null values, but only for those rows where home phone is null, right? So, we have a bunch of rows, but then all the rows that we have are where home phone is null, so there's 0 values of this set where home phone is present. Okay. Questions about that? That should be, you want to feel okay about that before we move on. Right, so count star is like existing rows, like just all the rows. Count a specific column is counting the number of rows that have non-null values of that column, right? Like present values of that column. Okay. Okay, so let's do this one. Write a select statement that returns the number of null values. So this is null values, right? In home phone, cell phone, and work phone. And so this is like how many missing values. So basically what you can do here is say, okay, select all from persons. If we just do that. Now, one kind of simple thing is to get the missing. Remember we can do total minus present phone equals the missing phone, right? So if this is the total number, it's just simple out. I shouldn't say it that way. But if total, right, equals the total number of rows should equal the number of rows with present phones plus the number of rows with missing phones. So then if we just you subtract right from each side. So we get total minus present equals the number of missing. So we can do select count star. So this is the total number of rows in the data set minus count of whatever we call it, home phone, right? So this is all the rows minus the rows where home phone is present should give us the number of missing rows. And that seems to work. And you can just put this as missing phone. And that's just the same logic for the other ones. Select total minus count of whatever was cell phones. I forget. Cell phone and then work phone as missing cell. work it. Near select count star as missing phone. Oh, I have a select statement twice. Right? And then the next one. Count star, this is work phone. Okay, as missing work. Something like that. Oh, this must be wrong. Maybe it's not. Is this what we had? I don't know. I guess it's the same. I guess it's right. I'd have to look at the solution. All right, but this is the logic, right? Is like total minus existing is a way for us to get missing. And this is pretty valuable. Like if you want to think about like validating a data set, it's pretty nice to be able to see, okay, how many missing values do we have in a data set? We can probably skip ahead here to some of the last problems. Let's do these last two. Okay. Display the work phone number for any cell phone numbers that are an empty string. Okay, and then I think I updated this to say then select the phone numbers that are still empty strings. Okay, so display the work phone numbers for any cell phone numbers that are an empty string. So what we can do is select all from persons, but it's really select cell phone from persons. You can say like where, just to start and get a sense of it, where cell phone equals an empty string. So we have these are all values where we have an empty string. We can, I think there's also an ID column, right? So now we're displaying the ID. And now what do we want to do? We want to, for any cell phone numbers that are an empty string, display the work phone number. So what we want to do is really use the coalesce function, right? But that only works with null values. So what you can do is first do null if cell phone is an empty string. So first we'll convert all our empty strings into null. And now you see we did that effectively. And then the next thing we want to do is coalesce, right? Coalesce only works with null, but now these empty strings are null, so we can coalesce the null values into the work phone value, something like that. Okay? And now you can see we're able to fill in a bunch of these with work phone numbers, but some of them, it must be the case, I guess, that some work phone numbers also don't have values, like have empty strings. So we can select the the phone numbers that are still empty strings. So we can say as phone, I guess, and then say where phone equals empty string, something like that. And this looks right now. Right, so you kind of like, I guess just how to take steps to get to, all right, for any numbers that are an empty string, display where cell phone's an empty string, display work phone. We don't really know, like we could have wrote a case when statement, I suppose, to do that, but we also can just coerce this into null using null if, and then use the coalesce function to say when it's null, use the work phone. And then the next step I say, we can delete this. Okay, so these are numbers, right, that did not have like either a cell phone or a work phone. Update the query so that the phone values that are empty strings display as null. The way to do that, right, we just again want to turn these empty strings into null. So I think we can do another like null if. So if it's cell phone isn't, like if we still get back to an empty string even when we're including the work phone, then we can say null if this whole thing is an empty string. And you can see, now I can remove this. We can say where phone equals null, is null. Right, so now we converted each of the empty strings to null because we wrapped this whole thing in a null if statement. Yeah, Julia?
So I feel like the where clause is redundant if the null if like function, isn't that already saying, like, if this value is an empty string, convert it to null? But you still need to say where persons is equal to the empty string?
Well, it's where the phone, so we have where phone is null. Like this will, if I don't have the where clause, it will display all the data, right?
Mm,
But if I just want to see, okay, did I properly like convert the, show me the
okay.
rows where now this is null.
Got you. Okay.
Now, one question is, shouldn't this where occur before these select statements occur? Typically, yes. I forget if it was Lay. I think it was Lay who dug deep into this. And maybe with like Postgres, for whatever reason. We're using SQLite, so I think we'd have to see if this worked with Postgres. But it seemed like maybe it even would work with Postgres. Because just remember, order of operations typically is like the where clause will occur before what happens in your select statement. So oftentimes it like wouldn't, it may not give you access to this. But anyway, with SQLite it seems to. All right. So this stuff is just like kind of fancy if-else statements with null values. Both when it's this, convert it to null. When it's null, convert it to this. Okay, so when it's null, we have an empty string. And, this is still sometimes an empty string. So even in that case, when you still have this remaining empty string, make sure those values are null. So the solution is there if you want to look through that. Other things about like null if and coalesce, right? Coalesce is when it's null, when the value is null, replace it with this value, right? Replace it with like a string unknown or whatever. And then null if is when this value, say that it's null if the value is whatever you specify, is like an empty string or -99, etc. All right. Yeah, I think the case when I updated, I know this one I think in particular was off, the answer, so I updated that. I think I'll let you look through them, the case when statements. And so what I want to do, let's quickly just like introduce window functions. We can always, and then I'll let you guys do the reading, practice it with a lab, then we can go back through window functions again. I don't mind giving the lecture twice if you don't mind listening to it. So we'll do, so one thing that's just like very valuable to do before you get started with any of these problems, and really like in life or whatever, is just make sure you understand the data, like all those other steps we previously did with, all right, what are the tables that are, how does one table relate to the other, right? It felt like with a case when statement, most of the questions, that I saw were really about joining tables together and just, a little bit confusion about how these tables relate. So that stuff isn't going to go away. And then I'd say with the window functions, or again, kind of with any of the data, you want to get a sense of the dimension for the data. So again, let me kind of say what I mean by that. So it's like, what does the row represent, right? Like if you're gonna plot this data, right? It's like a three-dimensional plot where like the date is on one axis, or maybe it's 2 dimensions, and the store number is on another axis, right? And I guess the transactions is maybe the third axis, right? So it's like, one way to think of, maybe you can think of it as many plots, is another way to think of 3 dimensions, where you have, maybe I can draw this. We have the date and the store number and the number of transactions. You can think of for a given store, I'll just plot it. Right, like for a given store, you have, like this is store 1. Right, and you have, this is the day, and then this is the amount sold each day, right? So it's like a good idea to just get a sense of what does each, represent, and this is day, and this is amount for store 1. But as you probably saw in the data, we have more than just store 1. We have store 2 up to like store 26. And for each of these, we have these 2 dimensions of amount and day. All right. And what you can think of, with window functions is there's actually like different ways of slicing the data. So here we're saying for this one store, let's go through the days. But another way we could do this is say, okay, well, here's the amount stored on here's the amount. Sorry, my handwriting sucks. But hundreds of students have dealt. Okay, and then for a given day, for the amount, and then we'll say this whole thing is like day 10. And now we have the different stores, store 1, store 2, store 3, right? And so maybe we show a plot as to how each store performs on a given day, right? That would be a different way of slicing, kind of looking through the data, okay? So we'll see like how with window functions we can work with that, but it's just like, it's very valuable to take a moment. Like you're not gonna be able to do these questions unless you like take a moment and are like, okay, what does this row represent? This is for a given store, there's 770 transactions. I guess that's sales, or maybe it's people passing through the register on a given day. Now I look at the next row. Okay, this seems like the next day, this is store number 1, right? And this is 2,111 transactions. So I might expect to see this store number 1 show up like many times. All right. Okay, so let's talk about window functions. So this is giving us a list of all the data, right? If we take the average of this will give us the average number of transactions per store per day, right? You see what I mean? Like we really have to just be specific about what this is representing. This is the average number of transactions per store per day, and this will just give us one value, I think. If I did it right, which I didn't. I might not have. Wrong number of arguments to function average. Select average star. Average, I should say transactions, shouldn't I? Okay, so this is the average number of transactions per store per day. All right, now what's notice that this reduces the dimension of the data down to just one row. So if you use a window function, it won't do that. Well, let's see this in a second. So I'll just copy this. Let's make these triple quotes. So let me make this bigger. Too big. All right, select average transactions. So instead what we'll do is we'll say select I just want to see all the rows. All the columns. Okay, so we'll say select the date. We'll do all the columns, date, ID, date, store number, and transactions, and average transactions over parentheses as average transactions. And now let's do this. So notice the difference here. This is the same number we got before. Right? This is the same number. So this is the average number of transactions per store per day. However, this time we are not reducing the number of rows, right? This is because a window function is really only specific to a column, where like I get to see all the columns I had existing. I kind of initially had, I just listed them out here, but now I'm adding this other thing that's saying, hey, let's display the number of transactions across, per store per day across the entire data set. And you can and we can maybe now compare, right? This seems like, not the best average, right? It's pretty below average. So already this is useful, I would say, because we can, see how well something did by, say, let's say we do the transactions. Let's do it this way. We'll do it this way. Let's see, this is the transactions minus the average. I want to probably do the average minus a store's transactions. Can I do it like this? No, I cannot. I wonder if I have to do, I broke it. I tried to push it. So this is like a store's transactions minus the average. I'm sure I can do it the other way. I would just have to look at it a little bit later to figure it out. But you can see how this would be useful. It's like the store. This actually is useful. This is probably the better way. This store did 924 less than the average per day per store, right? This one did above for the average per day per store. Okay. Let's go back to just like the ordinary window function, or the original thing example. In terms of the syntax here, really the only thing I did differently was I did over parentheses, right? Average transactions. So this over parentheses. We'll start to fill this in over time. But like this was the only difference. Notice if I did not do this, this would be the average It's going to reduce the dimensions of the data. We're not going to be able to see all the rows, right? We only see one row. This is normally what happens when we do an aggregate function, right? So this over parentheses is helping us to make the comparison. We can build on from there. Essentially, normally what the next step is then that you partition the data. So what this means is, let's do this. Let's order by the store number. Let's say ascending. So we're going to order the data set so that we always have, this should keep our ones together. So you see this? This is like the day. And here we have all store number ones, with this day. Okay, so from this, with the sequence of days. So the second, the third, the fourth, the fifth. Notice that the average transaction is the same value, right? This is the average transaction across all stores, average transactions per store per day across all stores. If instead we want to say just what's the average transactions for this store, right? We might want to say, well, how well did this number of transactions compare to this store's average? Not all, as opposed to all stores. What you do is you would partition the data. So we say partition by store number. So now what this will do is this will give us the average here just for store number 1. And then when we get to this thing, it'll give us the average just for store number 54. So let's take a look. So you can see this average changed, right? It's now 1523, but it's consistent for this store, right? This is the average for this store. And then same thing here. This is the average. This store, this is a different value, obviously, but it's consistent all the way for store 54. So now we can compare transactions of this store per day against this store, this particular store number 1 for all days. And the way that we do that is, again, we do the average transactions overward, and then in the parentheses we say, what are we partitioning by? Okay.
Can you partition by more than one column?
I think you can. I think we probably just put a comma here. But I'm afraid to try it. But it's we can't really do it with this data because say we partition by store number and date, well, we'd get a different average transaction for each row. You know what I mean? Which would just be this number of transactions. It's like the average for this store for this date is 2,111. So you need a higher dimensional data in order to do it. but we can try it. You see that? We have the same, each thing is only, we only have one example, right, of now our partition. I don't want to group, I want to do by date, sorry about that. The same problem. There's only one example of this store on this day. Maybe if we had like geographic data, right, like the same, like the store, like the multiple branches of the same store, something like that. No, that is what we have. Yeah, I don't know. We'd have to think about other examples. But yeah, you can partition by multiple attributes. All right, so the way I think about it is like the partition by is like when do you start over the calculation. So this is the same calculation for each store number, and then you start over when you get to this to the next store number, right? That's the way I think of a partition by. It's like when do I kind of reset the calculation. The next thing is, notice this is this is the same value. With window functions, you can also do a like running total. So let's say you do the way you'll do this is inside the parentheses. I'm going to say order by date, okay? And let's say ascending. We want to go from the earlier dates to, you know, the larger dates. So what this will do is this will give us a running average. So on the first day, the average number of transactions is just that first day. In the second day, the average is the previous day plus this day divided by 2, right? The third day, it's all these 3 days divided by 3, and so on. This can be particularly useful if you want to do like a sum, like a running total, right? To see like, all right, how much revenue am I gaining over time as we move through these days, right? So you can see that this is, transactions for the store on day 1, and then transactions for the store is these two combined, right? This plus this equals this. What else? And then when does this running total start over? Let's say where store number equals, we'll say like limit, if I say like limit 20, I want to see if we can get to start over to the next store. It starts over, right, with the next store. So it keeps getting bigger. This number just gets bigger. And then if we go to store number 2, so I'll say where store number equals 2. This feels off. It's fine. Here we start over again, right? The total number of transactions equals transactions for this day, and then it just keeps getting bigger. All right, so again, the partition by is kind of the reset point, right? So here we're resetting with each store number. If you don't have an order by, it will be the average, or if we have the average here, it'll be the average of each store, the average of a given store across all days. If you have the order by, it will be like a running total, right? Either a running average, or here we're using sum, so it's a running total. All right? That is the gist of it. Just remember, everything here just has to deal with this column, right? So it's not, or when you have order by date, it's not ordering the rows. I can still order the rows however I want, right? I can order by like average. I mean, this might be confusing, but you can order by different columns, and that will order the data set. This order by just determines what's next in the calculation, in the running total calculation. All right. So this is ordering the entire data set. Questions about this? Does this feel all right? I'm sure, this will be confusing when you get to the labs, I think. So this is like my main point. All right, so we want to pay attention to like the dimension of the data. So what do I mean by that? It's like this is each row represents what? So in this case, it's like each row represents a different movie, right? It's just a different movie. And now that we're in like this group by section, or really, you know, it doesn't even matter. What are we asking for now? We want a row for each genre and year. So in the above, we reduced our data to years after 2015, and we have a row for each genre and year. You can kind of see this, right? Like we started with the data being, you know, every single movie. That's what each row is, and we moved to the data being a different row for each genre per year, right? So drama 2016 gets one row, and comedy 2016 gets a different row. That switch in what a row represents should tell you that you need to use a group by. Okay, like window functions are not going to help you with changing the dimension of the data. Okay, they are only like column. Well, and you'll see this. They only like act on a specific column. They don't transform the dimensions of the row. So what I recommend doing is take care of the group by first. In other words, get the correct, like change your data so it's in the correct dimension, and then work on the window functions. That's the only way I'm able to do this stuff. Like my brain is not sophisticated enough to do it any other way. So
can you repeat?
Yeah.
Please?
So it's worth repeating, I think. So you can see that we have a difference in the dimension of the data, right? Because we have movies here, and we have year and genre for each row here, right? Each row is a different year, genre, drama. There are no more individual movies. Somehow we went from individual movies for an individual movie per each row to a collection, right? And that grouping is a group of movies, or really a group where it's a genre and a year. So this is our grouping. There are kind of like movies you can imagine in this group, and we've calculated the average of the length of movies in this group of 2016 movies in drama. So to solve these types of questions, what I recommend doing is to first put your data in the correct dimension. So the first problem to really work on is going from a one row per movie to one row per year genre, right? And that means that you have to do the group bys before you do the window functions, because group bys will change the dimension of your data. They will take you from, individual movies to a grouping of movies, right? A row representing a collection of movies. A group by will do that. A window function will not change the dimension of your data. Okay? So what I recommend doing is tackle the group bys first. Do the group bys first. Then save the window functions for last. So let me try to show you an example of this. So here I can see the rows. Let's start to solve the problem. So we select all for movies, and what do we want? We want movies where year, I think, is after 2015, and then we can start to move to the group by, and I'll do triple quotes. Okay, and then we'll do group by, and what do I want to group by? Well, what's the dimension of the rows? It's year genre, right? One row per each year, comma, genre. So group by year, comma, genre. And then we can, just to see what we're dealing with, we can just select year, comma, genre, right? And now run this. So this is already, I'm already feeling pretty good, because you can see all of a sudden the dimension lines up, okay? And now we can kind of fill in the gaps. So average duration per genre. This is a different value for each row, right? This is how long is, on average, is this genre's, or drama movies for 2016. That's a different thing than, what's on average comedy movies for 2016. So per this existing grouping, we want a different value, right, for each one of these. So this is really just using the average per group, the average per the existing group that we've already